steaming fish for a few minutes may be the healthiest way of cooking fish. A new paper shows that this cooking method is the best at slashing the cyanotoxins passed on to us, helping reduce associated health risks. There's one branch on the tree of life that laid the very groundwork for human life: cyanobacteria. These unicellular critters were the first organisms to use photosynthesis on a wide scale, and are the prime suspect behind the great oxygenation, or Earth's enrichment in atmospheric oxygen. So if you like breathing, cyanobacteria should be pretty high on your favorite things list. But lately, we've started so smarten up to the fact that they may, in fact, also be trying to murder us again by silently pumping a class of toxins, known as cyanotoxins, into freshwater supplies. Luckily, cooking can be used to limit the toxins that we get from freshwater fish, a team of researchers from the area of toxicology in the Department of Nutrition and Bromatology, Toxicology and Legal Medicine at the University of Seville reports. The study analyzed how different water-based cooking methods impacts levels of cylindrospermopsin in the widely eaten tilapia family of fish. The paper shows that steaming freshwater fish for more than 2 minutes slashes cylindrospermopsin levels by up 26%, compared to 18% for boiling. Another important find was that these toxins tend to pass from the meat into the water used for cooking, meaning a consumer would get the full dose of cylindrospermopsin if the fish stock is also used. More to the point, the study also revealed that steaming would lower concentrations of cylindrospermopsin below the doses specified by the WHO's provisional tolerable daily intake, meaning it should be manageable by your body without doing any harm. Our results show that it is not recommendable to eat raw freshwater fish, that it should be cooked, and better steamed than boiled, for more than 2 minutes, and that the water used for cooking should not be used for stocks, as it contains water-soluble toxins, which are transferred from the fish to the water, the authors explain. Being an emerging class of toxins, we don't yet know the full extent of cyanotoxins' effect on human health, or how the vectors that may expose us to them, but as a rule of thumb toxins aren't good for you, so we will work on that assumption. What we do know is that cyanotoxins can wind their way into crops irrigated with contaminated water. The same goes for cereals, and perhaps unsurprisingly, fish and shellfish which were grown or caught in contaminated waters. Up to now, they've been shown to affect viscera, among them the liver, kidneys, heart, intestines, lungs, and brain in animals, and have been shown to cause hepatitis, headaches, diarrhea, dehydration, kidney damage and more in humans upon ingestion. The lack of literature on this class of toxins recently prompted the European Food Safety Authority to call for more research into the transference and bioaccumulation of cyanotoxins in fish and other foodstuffs, as well as their toxicity in humans. It is fundamental to continue investing research resources in this area, as the real exposure to consumers is not known, and therefore the risk is also unknown, the researchers conclude. The team will now work on determining the effects other cooking techniques, such as grilling or microwaving, have on cyanotoxin levels in freshwater fish and then in other foodstuffs. The paper changes on cylindrospermopsin concentration and characterization of decomposition products in fish muscle by boiling and steaming has been published in the journal Food Control.